Let's try one more. So we get this formula, g of x equals negative 2x squared minus 9x minus 9. One thing to notice right away that's different is this negative 2 in front of the x squared. And I don't know if you'll remember this from before or not, but in general what happens is if you put a negative in front of the x squared, that's when you're going to have that upside down parabola. So that's something you can start keeping track of as we hit some more graphing quadratics in your 141 material. We'll talk a little bit more about what's happening, why that is, but for now that's just kind of a, I don't know, a little helper that you can use. Okay, so let's go ahead and for starters, let's find that y-intercept. You can do this in any order, but if you happen to remember that standard form, how it is right now, makes it really easy to spot y-intercepts. It's a great thing to do. The idea would be to find a y-intercept, you let x equal 0. And if you let x equal 0 up here, it wipes out the x squared and the x term, and all that's left is a negative 9. So we know we're going to be crossing the x-axis at negative 9. So let's say those are 2 apart. So it's going to cross. If your points that you're giving don't land right on one of your tick marks or something really obvious, you can always label them. I'm going to do that right here, and then if it's in my way later, I'll move it, but let's try that. Okay, so we've got a y-intercept. We would also like to find x-intercepts, which we do by factoring, right? So we're going to set this equal to 0, and we're going to work on factoring, and you can do that all at once or in whatever order you like. You can factor first if you prefer. Okay, so I'm going to factor out the negative sign. It always feels a little trickier to factor with the negative in there, and since absolutely everything is negative, I'm just going to remove that to start with. You do not have to. You can work on factoring with it in there. It just feels like it gives a little bit more in terms of options to worry about. Hold on. 2x squared has to split up into a 2x and an x. And a 9 can either be a 9 times 1 or a 3 times 3. And they're either going to be both positive or both negative. But if we want to get a positive 9 in the middle, I'm going to say both positive. If I do 9 and 1, I'm going to get 2 and 9, which is not going to add up to 9. If I do 1 and 9, I'm going to get 18 and 1 from my inside outside, which is not going to add up to 9. So let's say we probably want the 3 times 3, which is going to give me a 6x and a 3x, which do in fact add up to 9. So that's perfect. So this middle 9x is like your check for your factoring. All right, so we then want to set factors equal to 0. Sometimes this messes with people, but it's basically like you have negative 1 times all of that. So if you want to, you could say, oh, well, we have 3 factors. So either negative 1 equals 0, or 2x plus 3 equals 0, or x plus 3 equals 0. And this is just a false statement. It is not possible for negative 1 to equal 0, so you can just throw it away. So over here, we can solve and say, okay, well then x equals negative 3 halves, which means our intercept, x-intercept, is at negative 3 halves 0. Or x equals negative 3, which means we have an intercept at negative 3, 0. Okay, so negative, I'm going to make these 1, 3. So again, you can make your tick mark spacing whatever you want. Just make sure you label it. I made my x-axis have scale of 1 and my y-axis have scale of 2. So go ahead and do that as long as you clearly labeled and let me know. So negative 3 halves is really negative 1 and a half. Okay, so this is negative 3 halves 0. And then negative 3, 0. Okay, so I'm getting a pretty good opens down picture in my head. Last thing I want to do is find the vertex. So this is one where it's a little bit trickier. You could probably do that arithmetic in your head if you really needed to. But I'm going to go ahead and add them up and divide by 2. So negative 3 plus negative 3 halves. Divided by 2. Okay, so this is negative 3 is the same as negative 6 halves. So I am seeing a negative 6 halves minus 3 halves is a negative 9 halves. Remember that dividing by 2 is the same as multiplying by 1 half. So it looks like negative 9/4 is going to be the x-coordinate of our vertex. So what is that? 4/4 is 1, 8/4 is 2, so 2 1/4, negative 2 1/4. So negative 2 1/4. So somewhere along negative 1, 2, right around here is our axis of symmetry. Okay. And then to get our y value, feel free to use calculators. I'm going to see if I can crunch it really quick. I will plug this in. Let's write it this way. G of negative 9/4. Okay, so I get negative 2 times negative 9/4 squared minus 9 times negative 9/4 minus 9. Okay, so let's go ahead and calculate in Desmos. We could do that. It just looks really tedious. Okay, so to see using this as a calculator, click right in there, negative 2, negative 9/4. So you can just use the little caret button to get an exponent, or you can pop up this keyboard to get everything to push buttons to type it in. It's totally up to you. Minus 9 times negative 9/4 minus 9. And I get about 1.125. So back over here. I don't even think it's about, I said that, but I think that's exact. So right here in my picture, I now know exactly where that goes. And that's maybe a little high. I forgot I made my scale too. That is negative 9/4 or 2.25, 1.125. And again, absolutely feel free to check these in Desmos. You do want to be able to do this work by hand. For in-class testing, you'll either have a calculator or I'll try and give you reasonably nice numbers. I do expect you to be able to work with fractions, but I try and keep it a little bit neater than this one. This is just a little bit on the messy side, I think. Okay, so hopefully that helps. Thank you for watching.